but I'll be on it always, always.
Welcome back to the Pink Chemist. So today we are going to go over molarity. Now we got quite a few examples to go through, so I'm going to go ahead and hop right into it. So first things first, you want to write out this triangle. Now this triangle is going to help us to identify what formula we need to use in order to find the unit that we're looking for. So in the top, you're going to have mole, capital M for molarity, and capital L for liter. So these are all of our units, and based off of what we're looking for, this is going to help us to identify what formula we're going to use. So I am going to write out my given and my want. What is it that I was given? So in this problem, as we can see, we were given 0.5 grams of NaCl. We were also given 0.05 liters. Then we want to identify, based off of what the question is asking us, it says, what is the concentration, which concentration is just the molarity of the solution. So that means that we want to find molarity. Now that we have our given and our want, now we want to identify what is the formula that I want to use in order to find what it is that I'm looking for. So I see that I want molarity. So I want to come back over here to my triangle, and I want to go ahead and cover up molarity. Since molarity is what I'm looking for, I want to go ahead and cover that up. So now that molarity is covered up, it lets me see that I have mole over liter left. So that lets me know that my formula is going to be M equals mole over liter. That means since I'm looking for molarity, the formula I need to use in order to find the molarity is mole over liter. Now, when I look at my given, I notice that I don't have mole, but I do have liter. So I could go ahead and plug liter in, but I got to actually find the mole. So this is what I'm looking for, the mole. So I know that based off of my given, I was given 0.5 grams of NaCl. So since I was given that, that means that I can actually convert my grams to moles. That is something that I'm very familiar with. So I'm going to go ahead and set up to find my grams or my moles of NaCl. So in order to do that, I know that anytime that I have mole over grams, that my mole is always 1. And then when I see the unit grams, that means that I have to find the molar mass of NaCl. So I noticed that there are no subscripts for Na or Cl. So that means I'm going to go ahead and break it apart over here. Na, 1, 1. All right. And then when I look at my periodic table, I see that my atomic mass for Na is 23 and my atomic mass for Cl is 35. I went ahead and rounded it. All right. And then I'm going to take my calculator, and now I'm going to add those two values together. So 23 plus 35 equals 58. So when I add this together, I get 58. Now I'm going to put that right here, and now I have 58. So now I'm going to go ahead and multiply my 0.5 times 1. And then I'm going to divide, which gives me 0.5. And then I'm going to divide that number by 58. And then that gives me 0.0086. Okay. Now we'll use that. All right. So that gives me 0.0086. And I will just start right there. And I cancel that out. And so that's my number of moles. All right. So since that's my number of moles, now I see what my number is for moles. So now I could take that number and I'm going to go ahead and put that in my formula. So 0.0086. So 0.0086 divided by 0.05, and it gives me, for my final answer, actually I'm going to go ahead and bring this down here. So molarity equals 0.0086 divided by 0.05 liters, this is my mole, equals 0.172 molarity of NaCl. And this is my final answer. All right, so let's do another example. All right, so for example number 2, we're going to do the same thing. It's very important for you to go ahead and write your triangle. I'm going to go ahead and write my triangle down here. All right, so this is going to help me to identify what the formula is that I need to use based off of what it is that I'm looking for. Now, I'm going to write out a list of my given. So I was given, when I look at the problem, 3.04 grams of Cu, and I also was given 0.15 molarity, okay? Now, I gotta find it is what I want. The problem says what volume in liters was used to make the solution. So, if I'm looking for volume, that means that I'm looking for liters, all right? So I'm looking for the liters. Now, since I'm looking for the liters, I'm going to go ahead and I'm going to cover up what it is that I'm looking for, which now identifies what my formula is going to be. So my formula is going to be L equals mole over molarity. Okay, so now I'm going to plug in. Now, based off of the problem that I just did in the previous problem, I can already see now that I need mole, being that my given does not provide me with the mole, but it does provide me with the grams. I know that that means that I need to convert grams to moles in order to plug in my number of moles for my formula. So I'm going to go ahead and start there. So I'm going to go ahead and take 3.04 grams of Cu. I'm going to take a little track. I got grams of Cu here. I'm looking for my mole of Cu. All right. I know when I have moles over grams, my mole is always 1. And then I have to find the molar mass of Cu. And let me look at my periodic table. I only have 1 Cu. So my molar mass, and I am going to round it, my molar mass for Cu is going to be 64. With that, I am now going to do the math. So I'm going to take 3.04, put it in my calculator, and divide that by 64. And that is going to provide me with the answer of 0.0475. Okay, so this is my number of moles. So now I can go ahead and take my formula of L equals mole over molarity. So I'm going to go ahead and take that 0.0475 and divide it by 0.15, which is my molarity. And then I am going to put this in the calculator. And I get 0.32. Now, in the calculator, it's going to give you 0.3166 and so on. But I went ahead and just used the first 2 values after the decimal, and I went ahead and rounded. And then that gave me my number of liters. And that's my answer. All right. Let's go ahead and go to the next example. And this is our final example. So, again, first things first, what we want to go ahead and do is we want to write out our triangle. This is very important, writing out our triangle, because this is going to help us identify the formula we need to use in order to get what it is that we're looking for. Okay, so I'm going to make a list of my given and my want. So I was given 4.00 molarity of a solution, and then I was also given 12 liters of a solution. All right, and then it is what I want. It is asking me how many moles. So I want to find mole. All right, So again, I'm going to go to my triangle. I'm going to cover up what it is that I want, which is in this case is mole, which now provides me with the formula. In order to get my number of moles, I have to multiply molarity times liters. That is my formula in order to find moles. So I'm going to go ahead and based off of what I was given molarity and I was also given liters. Okay. So I'm going to just go ahead and plug in. So my mole equals M, which is 4 times liter, which is 12. So 4 times 12 equals 48. So my number of mole for this is 48. And I'm done with that. Now, on this next slide, what I do want to make note of, I do want you to make note of something. In your problems, they will not all the time give you the volume in liters. Sometimes they may give you the volume in milliliters. So, for instance, let me go ahead and write out a problem. If I add 25 milliliters of water to 125 milliliters. Okay, I'm gonna just stop there of a 0.15 molarity solution. Okay, I'm gonna write this because this is more of a dilution problem that I'm writing out right now. However, I want you all to be able to see what you would need to do if you were given milliliters instead of liters. So what you would need to do is anytime that you're given the milliliters instead of the liters for your volume, you would need to convert your milliliters to liters. And so what you would do is you would take your number of milliliters and literally divide it by 1,000. Okay. Once you divide it by 1,000, that is going to give you your number of liters, which in this case, this would be 0.025 liters. Now, if you are in my class and you actually take my chemistry class, you know that we do it by setting up our railroad tracks, listing our given and our want. So I would do it for the 125 milliliter. So if we were given 125 milliliters, okay, and then we want to find liters, we know that we have to duplicate right here milliliters so that milliliters can cancel out. And I know that 1 liter is in 1,000 milliliters. Okay. So this is just for your visual if you are in my class, so it can make sense to you. And then you do the same thing. You take the 125, you divide it by 1,000, and then that is going to give you 0.125 liters. So this is important to note when it comes to converting between milliliters and liters when you have problems that do not give you the volume in liters immediately. So I hope that helps, and I will see you in the next video.
Don't play with it, don't be the size.